Hey guys, I just want to take a couple minutes to go over how I expect you to annotate your gels. Once you're in PowerPoint, you can go ahead and insert the image of your gel after you've downloaded it from D2L. Okay, so just go to Insert and then Pictures. Next, we want to crop out any regions that aren't important for sharing your data. So for instance, since I want to just focus on the results from this gel, I'm going to go ahead and crop out the other one. All right, so that's really all of the image that I want to show. Just straighten that out a little. All right, so next you can label your wells. And there are two ways that you can do it. You can either number them.
I cleaned the wheel. I cleaned it.
Not right now, in a little bit.
I do not like walk. It's just so boring.
Just label that ladder. And now you want to indicate the size of the bands. We only need to focus on the range that's near your DNA bands. We don't need to label all of the ladder. Just gonna reduce that font size a little bit. All right, so 100, 200, 300, 400, and 500. Hopefully, I haven't checked our size of the gel pilot. Now you can highlight all of them, go to arrange and align. I'll just align left. All right, now I'm going to copy and paste to label the other side. Some people like to add arrows pointing to the bands. I don't think it's necessary. Okay, so then you would group it. Copy it, open up Word, and in your results section, you want to insert a text box. Just do simple text. I'm going to go ahead and paste the image. I'm going to paste it as a picture. Okay, just expand your box. And then you want to describe your figure at the bottom. So let's call this figure 1. Human PCR gel. You don't need to put any details about how the gel was made here. That's all going to go in your method section. You just need to let your readers know exactly what is in each well. So let's go ahead and describe them. Lane 1, it looks like that's empty. 2, okay, so that's the PTC, that's the PTC amplicon digested with FNU for H1. Actually, let's just call that SAT1. I'm going to go ahead and put in parentheses the sizes too. These aren't the exact sizes. You can look them up in the reference paper. Sizes A, L, D, H, G, L, E, L. Put the sizes in parentheses. PTC uncut. Which we can see with this uncut, if we compare to the PTC digested, there's a band that's the same size as the uncut, but there's also the digested band. So that would indicate that this person is heterozygous taster, right? He has the polymorphism for both non-taster and taster. This should be the SLC6A3 PCR. Indicate those sizes of each band. Remember, in your results, you're going to describe or interpret all of these results. Okay, so I expect you to explain what the results mean for each of these PCRs. So for the SLC6A3 PCR, you should be able to look at your gel and determine how many repeats you have in the 3' UTR of the SLC6A3 gene. You can calculate how many repeats there are by taking the size of each band and then dividing by 40, since each repeat has 40 bases. So some of you, actually everyone will probably see 2 bands if the PCR worked out well. One that you inherited from one parent and you inherit a different set of repeats from the other parent since you're diploid. Now, it seems like every PCR also has these 2 lower bands. That could be some non-specific binding or some serious primer dimers going on. Right, I'm also going to indicate the ladder that we used. Gel pilot 100 base pair plus. Okay, so that's all you need to do.